Okay, so now we're going to work backwards, okay? What would my polynomial be if my zeros were 1, 2, and negative 3? So now we're working backwards. We have x equals 1, 2, and negative 3. What is the step that came before that earlier? Well, we had these. So we have, it's basically the opposite. So x minus 1, right? Because if x is 1, this would make this 0. We have x minus 2 and x plus 3. Okay? So hopefully you can see back and forth where these are coming from. If x is 1, this is 0, which makes this 0. If x is 2, it makes it 0. And if x is negative 3, it makes it 0. Okay, so now I'm going to multiply all these together. So I'm going to leave the x minus 1 out here for a minute. X times x is x squared plus 3x minus 2x minus 6. And that gives me x squared plus x minus 6. And now I'm going to multiply these. So this is x cubed plus x squared. X times negative 6 is negative 6x. And now I go through with the negative 1. So negative x squared minus x plus 6. So my x squareds cancel out, and I have x cubed minus negative 6x minus x is negative 7x plus 6. So if I were to factor this, okay, it would factor down to this, all right, and my zeros are here. So if I plug in 1, say I plug in 1, then I have 1 minus 7 plus 6 equals 0, and that works. And it will work for 2 and negative 3 also. Okay. Now, what if my roots were negative 2 and 1 plus the square root of 7? Because when we are solving for x and we use the quadratic formula, a lot of times we get answers in this form. So what do? How do we work backwards when we have something like this? Well, right now we don't have the tools for that, so let me show you what you need. The irrational conjugates theorem. If f, I thought it was if f be a polynomial, sounds like a pirate, let f be a polynomial function with rational coefficients, and let a and b be rational numbers such that the square root of b is irrational, okay? So this is all math hoity-toity language. If a plus the square root of b is a 0 of f, then a minus b is also a 0 of f. That is the main part that you need to know, okay? So a plus the square root of b will always go with a minus the square root of b. They're always together. And that reminds me of these conjoined twins. Sorry, I know it's kind of weird. But these are like twins, right? Okay, in other words, if one of your roots looks like this, then its conjoined twin has to be included, and it looks like this. This is an actual real person. I don't know if you, or people, I don't know if you've ever seen them before. Anyway, so they go together. So, for example, if 2 plus the square root of 3 is a root of a polynomial, then 2 minus the square root of 3 is also a root of the polynomial. And why do I think this is so cool? Look what happens when you multiply them. Look, we have a plus b times a minus b equals a squared minus b squared. I set the alarm on this thing and I don't know how to turn it off, so it keeps beeping. Okay, so what do? 2 times 2 is 4, okay? I square the first minus the square of the second. Well, the square root of 3 times the square root of 3 is 3. So I get 1. This one, 5 times 5 is 25, minus the square root of 7 times the square root of 7, which is 7, and that gives me 18. And finally, 2 times 2 is 4, minus the square root of 7 squared is 7, and I get negative 3. So I think those conjugate twins are awesome. Okay, so let's go back to this problem that we have. And this actually, hang on a second. This is actually the last problem, and it is rather involved. So I'm going to do that on the next video.